Imagine sitting down for a year-end review. The spreadsheets are tallied, and the bottom line reveals a massive direct labor cost overrun. What you are looking at is the total flexible budget variance. This is the mathematical difference between what you budgeted for labor costs and the actual cash paid out to your workforce. The limitation of this single variance figure is immediate. It provides zero operational context. It alerts you that money was lost, but it offers no diagnostic value for fixing the leak. A top-level variance calculation cannot differentiate between two very distinct problems. It cannot tell you if you paid your workers too high of an hourly rate, or if your workers took far too many hours to complete the job. To establish real accountability, that single variance number must be split into two independent levers: the rate variance, which measures price, and the efficiency variance, which measures time. Relying solely on a total variance figure makes targeted corrected action impossible. You have to break the number apart to see what went wrong on the floor. This bifurcation is critical in manufacturing, but it becomes the core of profitability in service environments. Think accounting firms, law offices, or consulting agencies. Unlike a factory churning out physical goods, a service organization invests very little capital in raw materials or supply chains. Instead, direct labor represents the majority of their operational investment. The expertise of the staff is the inventory. Because human time is the primary product being sold, minor deviations in hourly wages or task completion times compound rapidly across an entire firm. Mastering the distinction between how much you pay your people and how efficiently they use their time is the foundation of financial control in the service sector. To understand exactly how these variances separate, we can plot our labor costs on a Cartesian plane. We have hours, or efficiency, on the x-axis, and wage rate, or price, on the y-axis. We start by plotting our standard budget expectation. This creates a baseline geometric shape representing what the job should cost. The height of this shape represents the standard rate, the hourly wage we expect to pay our workers based on current contracts and skill requirements. The width represents our standard hours, the precise amount of time we budgeted to complete this specific production run. Calculate the total area of this blue rectangle, and you have the total budgeted standard cost for direct labor. Any deviation from the exact dimensions of this blue shape represents our variance. Let's look at what happens when the production team takes longer to complete the job than budgeted. The baseline rectangle stretches outward along the x-axis to reach our actual hours worked. This new vertical slice of area added to the right is the direct labor efficiency variance. To calculate its exact size, we take the actual hours minus the standard hours and multiply that extra time by the standard rate. Notice that we multiply by the budgeted standard rate, the original height of the box, rather than any actual wage paid. Holding the price constant is the mathematical way to isolate the pure cost of the extra time. If we introduced a wage change here, the calculation would be contaminated. This specific yellow slice represents the financial penalty of operational sluggishness, stripped of any wage fluctuations. Now we introduce the second variable. The actual hourly wage paid to the workers was higher than our standard expectation. The entire top edge of our shape shifts upward to the actual rate. This new horizontal block running across the entire top is the direct labor rate variance. We find this area by taking the actual rate minus the standard rate and multiplying that price difference by the actual hours worked. It is crucial that this formula multiplies against the actual hours, the full new width of the shape, not the standard hours. The company had to pay that higher wage for every single hour the workers were physically on the clock, including the overtime hours from the efficiency delay. But actual hours ran long, hitting 53,625. The difference of those hours, multiplied by the 550 standard rate, gives us a yellow efficiency variance of $22,688 unfavorable. Simultaneously, the actual rate paid was $6 flat. That 50-cent rate hike, multiplied by the massive actual hours worked, adds a red rate variance of $26,813 unfavorable. To find the overall impact on the budget, we simply sum the values of our two geometric additions. Adding the specific rate and efficiency areas together perfectly matches the total flexible budget variance of $49,501 unfavorable. The geometry proves the math. Let's step away from the analyst's desk and look at how this plays out for an operational manager making real-time staffing decisions. Suppose a manager decides to assign highly skilled, specialized workers to a production process that was originally budgeted for standard, unskilled labor. Because skilled workers command a higher wage, this decision immediately triggers an unfavorable direct labor rate variance. The price is undeniably higher. But here is the operational paradox. Those skilled workers will complete the task in significantly fewer hours. The savings generated by this favorable efficiency variance can completely offset the unfavorable rate variance, resulting in a net financial gain for the company. A competent financial controller knows never to punish an unfavorable rate variance without first evaluating the efficiency return generated by that exact investment. But now consider the exact reverse scenario, where direct labor efficiency suddenly plummets because the entire production line unexpectedly grinds to a complete halt. If workers are supplied with low-quality, brittle materials, they will spend extra hours clearing machine jams, recalibrating equipment, and discarding defective parts. All this wasted time gets billed to the production manager as a massive, unfavorable labor efficiency variance. But the root cause wasn't on the floor. It happened when purchasing bought cheaper materials to secure a favorable material price variance for themselves. The complete variance report proves that the savings from the cheap materials were entirely erased by the cost of the extra hourly wages required to process them. Standard cost variances function as a holistically linked diagnostic system, revealing the true operational health of a company through its interconnected data.